Hello, and welcome to APICS Extra Live, Reducing Safety Stock with Risk Pooling with Chris Harris, DBA, and Thomas Parker, PhD. My name is Christopher Jablonski, Staff Editor with APICS, and before we begin, I'd like to run through a few details. At the end of the presentation, we'll save time for a question and answer session. If you look at the right toolbar on your screen, you'll see a questions box. To ask your question at any time during the presentation, simply type it in the box and click Send. And should you experience any technical difficulties during today's broadcast, please call GoToWebinar support at 1-805-617-7000. This presentation is being recorded and will be available at apics.org/extralive early next week. Now it's my pleasure to introduce our speakers for today's broadcast. Chris Harris, DBA, is an Associate Professor of Supply Chain Management in the School of Business at the University of Indianapolis, Indiana. He's co-author of the Shingo Prize award-winning book, Making Materials Flow. And he's co-authored 3 other books and multiple articles on lean production systems, and he serves on the board of the Central Indiana APICS chapter. And Thomas Parker, PhD, is an assistant professor of supply chain and operations management in the School of Business at the University of Indianapolis. He teaches operations management, operations strategy, purchasing, and quantitative methods, and he has more than 15 years of professional experience in the automotive industry. So now I'd like to turn it over to our speakers. So Thomas, and Chris, please take it away.
Hello, everyone. This is Chris Harris. I'm going to lead you through the first part, and I'm going to hand it over to Dr. Parker when we get to talk about the part about risk pooling. Our agenda is to try to build up a lean material system and show you how risk pooling can fit into that. So we're going to have a discussion over purchase parts supermarkets, the external flow of information and materials, the internal flow of information and materials, risk pooling, and then we're going to leave time for conclusion and questions. So to get started, the purchase parts supermarket, let me tell you a story here to illustrate what we're trying to do. I want you to imagine that for some reason I've ordered 50 marbles. I've ordered 10 white ones, 10 red ones, 10 blue ones, 10 green ones, and 10 black ones. I think that's 50. And I want you to imagine a traditional facility where you get a shipment receipt in the receiving door, and you just ship it out to where it's used on the floor. So in my marble example, somebody comes to the door, I get the 50 marbles, and I just throw them in the room, whatever room that we're in. And now my question is, are you willing, how confident are you if you leave the room for an hour and come back that all those marbles are still in the room? My point here is that we don't have a good way of monitoring that material. What a purchase parts supermarket does is it allows me to put all that in one place. So I want you to imagine now we've got those 50 marbles and we have a small tray with a spot for 10 white ones, 10 red ones, 10 green ones, and so on. Well, now I look at that, I can immediately tell exactly what I have. This purchase parts supermarket is going to act as the base of operations for the material flow system in a lean manufacturing facility that operates this way. We originally brought this up in the book Making Materials Flow that was published by the Lean Enterprise Institute in 2003. And we broke it down into different parts. We had the plan for every part, which we will not discuss today, the supermarket, pull signals, and then the route, all of which we will discuss because they're important to allowing us to capitalize on risk pooling. The benefits of a purchase parts supermarket is that it does provide the opportunity for better inventory control. A purchase parts supermarket is where all purchase components in a facility are carried. Now, that sounds like a big statement, but there's many reasons for that. One of the big ones being is it acts as the base of operations for material flow and information flow. So we have these 2 different types of information flow and material flow that are going to happen. We're going to have it external from our supplier to us and internal from our purchase parts supermarket to the production floor. The supermarket, that base of operations, allows us to do that, and it allows us to effectively do that. The next step in that is that when we have all those purchase components carried in one place, it gives us the opportunity to pool risk in the form of variation with those components. So what we're going to do now is we're going to talk through each one of those, how you size the supermarket, which is going to be the first step. How do I size that? And the next step is going to be external information flow. How do I keep that supermarket full? Internal information flow. How do I keep the production floor full? So how you size the purchase parts supermarket is really pretty basic. Our formula taken from Making Materials Flow here is the daily usage times the shipment size plus the supermarket buffer or safety stock. However you turn that, however you do that. But the main point here is if you get it once a week, there's probably going to be 5 days on it, assuming you run this part often. Well, your daily usage is 100 pieces, so you've got 500 there, and that's really, you have no choice there, right? Because if you get a shipment and it's got 500 pieces on it, you really need to have room for that maximum inventory level there. And then you add on that safety stock or that buffer stock, however you tend to do that. This is a real number. There's not a lot of conversation that goes into this. You got to have room for what shows up. And then once we do that, now we have our supermarket. So if you look here, here's our supermarket that we're talking about. We've just sized that based upon the frequency of delivery and amount. In other words, how much is on a truck when I get it. That's pretty much how we're sizing that, plus our safety stock or our supermarket buffer. Then we're going to have the supplier here, which is external to our facility, and we're going to have the production floor, which is internal to our facility. It's important to note that this purchase parts supermarket is inside the facility. We like to put that as close to the receiving dock as we can to eliminate wasted effort from the receiving dock into the market, because once it goes into the market, then we are ready to use it. It is ready to be part of our production system. To do this, we're going to use Kanban signals and Kanban cards. There's a lot out there about this. I personally like the cards, but I also recognize the difficulty that many of you have probably had dealing with the cards. And so a lot of people use what they would call a two-bin system. Some people just use bins as pull signals. There are some dangers with that. If you lose them, they can become footrests, they can become trash bins, they can become lots of things. And if I use them to signal my inventory and I misplace them, then it becomes very difficult for me to keep the production floor full of components. Over here, we've got the other side where we've got to keep this pipeline full from the supermarket to supplier. So once we've got this set up with the maximum inventory level, how do we make sure that this stays full? And then how do we make sure the production floor has the components that they need to produce product? The formula that we're going to use to calculate this. This formula comes out of the book Lean Supplier Development with a copyright of 2011 published by CRC Press. It's one that we wrote to really attack the supply base and the relationship between our production facility and them. And this formula specifically is how do we fill that pipeline? The pipeline that we're talking about pertains to the external flows of information and material. Information going to the supplier and material coming back from the supplier. And we're trying to use a just-in-time philosophy here. Mainly, that is based on replenishment. You use one, I will then bring you another one. If you take a look at our formula here, it looks a little difficult here, but I'm going to talk you through that. But we're trying to, as the top bullet point there suggests, we need to size these so the pipeline of raw material and components is sufficient to consistently replenish the purchase parts supermarket. So if you take a look at that, we're going to take the average daily usage times the partner's time to replenish. Now, in this book, we use the term partners because what we noticed was as companies go from facility to facility competition to supply chain competition, that relationship between suppliers and us really needs to become more of a partnership because we need to do what's the most beneficial for the entire supply chain to compete on a global scale. So when you see partners' time to replenish, you can also think of that as the supplier's time to replenish. In other words, when we send them an order, how long does it take them to make that order? The transit time is how long it takes to get from their facility to our facility. So that's a pretty straightforward one. The reorder period is how long it takes us to reorder the product once it's been used. Or in the case of a lean system, once that box has been opened and that pull signal goes back, how long does it take for maybe the purchasing organization to reorder that part? And then we have the purchase parts buffer, which is the safety stock or buffer that we talked about when we were sizing the maximum inventory level. And the one that it may be a new term for you is the pull quantity. And the reason for that is we ran into a problem. I'm going to go back a couple of slides here. When we were doing this, because when we were writing the book on supplier development, because this is what we say is the pull quantity, and this is what we would say is the standard pack. And the reason was pretty simple, really. Let's say that from the supplier you get a pallet of material, but you release it to the floor by the box. Well, those are two different quantities. And so we couldn't really call this one the standard pack because it would not coincide with that one. Whereas when we wrote Making Materials Flow, this was called the standard pack quantity. So pull quantity is the amount that you pull from the supplier when you pull that material. And for pieces of our discussion here, we're going to say I pull a pallet and I deliver it to the floor by a box. Illustrate this. And what I'm trying to do is show you how this fills the pipeline. So let's say something's been used out of the market, the purchasing department gets it, and they reorder period is 1. So they get it, they order it that same day. Then it goes here, it takes the supplier a day to make it. That's the part there's time to replenish. Sorry about that. Then it goes to here, it takes a day to get here, and I have a day's purchase parts buffer. So if I run this right and everything runs well, of course we're all in materials, we know that's really not the case, but assuming things ran well, this pipeline would be constantly full. So at this point, we've sized the supermarket for the maximum inventory level. We know what our inventory levels should be, and now we know how to keep them full. The next step is, how do I physically do that? If you use a card, it becomes pretty difficult, right? Because you probably are going to have a board at your receiving and shipping dock saying, this is what I sent out to the supplier, this is what I received back from the supplier. The goal would be to really, I know this is kind of an odd statement, but to really not even have a reorder point per se. But as soon as that is pulled out of the supermarket, this card would be scanned and an electronic signal sent right back to the supplier. And that way we've got this constant flow of material back in. The Kanban signal really plays a big part in just making that information flow so that those materials can come back in. This is just a simple example that we developed of what one might look like. Most of them that I deal with are much more detailed. But you can see that we've got the pull quantity down there, the part number, the part description, and the supplier information as well. Next part of that, assuming that we have everything that we need to this point, we've got this is right, where we did the maximum inventory level. This is right, this loop to make sure that's full. Now we have to get this right. How do I make sure the production floor gets the parts? I think that many of you would agree with me. If you were to go out and talk to the production floor supervisors and you said, what is some of your biggest issues? One of them would probably be, I can't get the right parts at the right time. And this system is going to allow us to attack that problem. Because I know that I'm going to get the parts, I know that they're there. The next logical, how do I make sure that I get them to the production floor effectively? What we're going to have to do is we're going to have to size this loop and talk about how this happens. To size this loop of cards, we're going to use this calculation taken from Making Materials Flow. It's the average hourly usage times 3 times the bus route frequency divided by the standard pack quantity. This is assuming it's a coupled route. Now I'm going to go into detail as what is a coupled route. But if you'll follow with me here, I think we can do what we need to. First thing is this is the information flow between the purchase parts supermarket and the production area. In other words, this is the internal material and information flow. And what we want to talk about here is the difference between a bus and a taxi. So if you think about a taxi, one time I think I was at one of the big airports in New York. I can't remember which one, and I got off at the wrong terminal. And I had to get a taxi ride to the other terminal. It was only like 2 minutes, and the taxi driver wasn't very happy with me because it was a short ride. But you can understand why the taxi driver was not happy, right? Because they have to sit there, and they have to wait, and then they get a fare, and it was only a $2 fare. So I understand why the guy was upset with me. But if you think about how a taxi works, they go somewhere, they drop people off, they charge a good fare, and then they drive around looking for another fare. In other words, there's a lot of time wasted between fares a lot of times. Well, if you think about how your forklifts work in a factory, you go and you take something out and you come back and you're probably empty. And then you wait for something to take something somewhere, then you fill it up and you go back. It's a very chaotic process of you only take material where there's noise, where somebody says, hey, I need material. I've never liked the term water spider because I don't know if you've seen a water spider, but they're very herky-jerky, right? They go one place or another. And that doesn't seem like a very good way to deliver material. When you compare it to a bus goes by every whatever the cadence is. Maybe it's every 1 hour. Well, every hour I'm coming by to see if you're okay. Let's think of it this way. I go by process A and I say, are you okay? And the way that I say, are you okay, is with the Kanban cards. If you've used some, I pick them up, I'm going to get you some more. That's how I know if you're healthy or not. But it's no longer of I'm waiting until you need me. I'm being very proactive with a bus route by coming by you every hour. The term that we use is we kind of coined for this article is the material transit route. And if you think of that, the material transit route would be like a tugger pulling carts behind them, coming by on a route every hour. So if you have a problem and maybe you didn't use any, that means I'm not going to bring you any more. Or you used a little bit more, I know that something happened, and so now I know that I need to bring you a little bit more. Either way, I'm coming by every hour on a route, and you know that I'm coming, which is a drastic difference from the traditional material flow that would say, I'm only going to bring you stuff when I have a problem. Here's how we size that loop of information. Now, if you think back to my original slide, we had the 3 big points. We had the supermarket that we were going to size. Then we had the external material loop that we formed. This is the internal. And so we take the hourly usage times 3 times the bus route frequency divided by the standard pack. So in this case, we'd have an hourly usage of 25. We'd multiply that by 3 if it's a coupled route, and I'll show you that in just a second, divided by the standard pack quantity, which would be 25. That means there's going to be 3 pull signals in this loop. Now, I know this is kind of difficult to comprehend with words, so I'm going to show you an illustration here to try to better discuss this. Here's the production area, and here's my tugger driver. 1, 2, 3 signals. So if you go back, that's the 3 signals we came up with, all right? They're going to use 25 in an hour. So you automatically notice there's a 25 buffer here, an hour's worth of buffer. That's right. I'm a firm believer that just-in-time means kind of almost just-in-time. That's in case I have a problem. That's in case they would make something a little too fast. That just gives me a lot of buffer to make sure that the system runs well. So an hour goes by. There's one empty here. There's a full. There's a full. The tugger driver is now going to drop this. And so if you've ever heard the terminology, 2 hours line side, 1 hour delivery, this is what you're looking at here. 2 hours line side, and there's an hour coming. When that happens, now there's an empty one. I deliver this. You can see there's 2 there, and now this person goes back to the market to load this. This is called a coupled route because I've coupled the delivery process with the loading process in the supermarket. Let's go through it again. This person's just loaded this. They're on their way out. About the time they arrive, there's an empty one, and then there's the one that's there. We deliver, and now we go quiet 3 times the route frequency. 1, 2, 3. Remember, this is just the cards. This is the information that we're looking at. This person's going to do 3 things at every stop. They're going to deliver product. They're going to pick up the empty containers and pick up the pull signals. Now, if you were to be using containers for pull signals, then, of course, that person will be doing 2 things, delivering the product and picking up the empty container. The interesting thing about this system is it will fix itself if you have a problem with production. So let's go back a couple of slides here, and we're going to take a look. Oh, that's not back. Let's say that the production area breaks down right now. All right, if the production area breaks down right now, they're going to go ahead and deliver this product here. Right. Now, once they deliver that product, they're going to go. They have no other empty to deliver. So the next hour that they come by, there's not going to be anything to deliver. And this can go on until the production area gets back up and running. As soon as the production area is back up and running, everything will go right back to normal, where the person would be empty here and then go back and deliver as normal. This is called a coupled route. A coupled route, when you have a person driving the tugger and you have a person in the market loading. So in other words, I've decoupled the delivery process from the loading process in the supermarket. So now we go and we deliver right here. This is going to be delivered. This is empty. This is delivered. Now I've got my empty one. Now it's line side 1 hour delivery. The time of delivery does not change. And this goes back, and this person loads it in the market, and this one is picked up to take it back out. You still have the 1 hour buffer, and this operates the same way. It fixes itself as well. It just can, if you do the math, it may take you another hour to get everything back in the run, but the production area would not be in trouble because they would have the parts in front of their line. One thing that people immediately jump to when we talk about this is, well, that's going to raise my inventory level. Well, if you recall, when we calculated the maximum inventory level, we never talked about whether it was a coupled or decoupled route. We talked about the daily usage and how often you receive the material. This just allows me to take the material back out to the floor. The amount in here is not going to change. I guess if you were a real stickler, you could say it may change by an hour. But as far as in reality, this is just going to continually flow this way. Whether it's coupled or decoupled, this material is going to consistently go out to the production area. So what we've covered so far is enough information, I hope, to get us to where we can have a conversation about risk pooling. So to this point, we've talked about how you size this, right? And the part of that we didn't get into a lot of is the safety stock purchase part buffer. But this is based on how often you receive the material and how much you use. This loop was the external material and information. How do I make sure this stays full? This was the internal information loop that shows how the production floor doesn't run out of parts. And the caveat to that is that it has to run like a bus route, not like a taxi route per se, because I want to make sure that they're consistently getting those products. And these were the two formulas that we used to do that. And so at this point, I'm going to turn this over to Dr. Parker here, and he's going to cover the concept of risk pooling.
Okay, so risk pooling is a term that we use to describe the reduction in the amount of variation that a purchase component experiences when we aggregate the demand for that component across all usage points. The basic idea is that there is less variation in the demand for a purchase component when you combine the demand across all locations as opposed to treating each location as a separate usage point. This reduction in variation is a result of the tendency for high and low component usage areas to smooth out the overall demand per component in a given period. If we consider the following example, here we have a fictitious component that is used in 5 different production locations. When you compare the usage of this component, you can see that there is considerable variation in demand from month to month, as well as from one production area to another. When we calculate the variation as a percentage of the average annual demand for each of the areas, what we find is the demand for this component varies from a low of 4% to a high of 101%. As we can see from the table, this component has much different usage characteristics depending upon the month and production area you're evaluating. When we aggregate the 5 areas for each of the 12 months and then calculate our percent variation, we find that it equals approximately 17% of the annual demand. This turns out to be considerably less than when we consider each of the areas independently. This reduction is a consequence of the smoothing effect mentioned earlier. Essentially, the amount of variation for the averages of the component demand is less than the amount of variation for the demand when you consider the areas separately. So this leads us to the question of how does a purchased parts supermarket affect inventory levels? The traditional way of dealing with variation in either demand or delivery is to increase the amount of inventory we carry. This extra inventory is known as safety stock and typically is calculated based upon the standard deviation of the demand over the lead time for a given component. The level of safety stock is a function of the customer service level the organization chooses to provide and the amount of variation in demand a component experiences in a given period. While customer service levels will vary depending upon customer and or industry, most organizations which operate in a make-to-stock environment will have fairly high customer service levels. In the following example, we assume a 98% service level and a lead time of 1 month. If you were to ignore the pooling effect and treated each of the areas independently, then for each usage area, you would calculate a safety stock quantity based upon the component usage, the customer service level, and the standard deviation of the demand over the lead time for that area. For our example, this translates into 2 times the standard deviation of the demand for each area. In this table, we can see that the effect that the variation has on our total inventory levels when we consider each location separately. The safety stock quantities vary from a low of 7 units to a high of 130 units. The overall amount of safety stock required to achieve a 98% service level for the 5 areas in this example would equal 298 units. When we repeat the same calculation for our pool demand, what we find is our purchase parts supermarkets would only require 162 units of safety stock to meet the 98% customer service level requirement. This equates to a 45% reduction in the amount of safety stock inventory. By pooling the demand over the 5 production areas, we were able to significantly reduce the amount of variation in the demand for this component, which in turn reduces our need for safety stock. This reduction in safety stock inventory can be achieved without jeopardizing customer service levels. If you expand this concept across all the organization's purchase component inventory, you can begin to see the potential a purchase parts supermarket has for reducing inventory levels and costs. In this presentation, we've demonstrated some of the benefits associated with a purchase parts supermarket. We've shown how this concept can improve the flow of parts associated with information both internal and external to the organization through the use of Kanban cards and material transit routes. We've also shown how the purchase parts supermarket can improve inventory control and visibility throughout the production area. And we've demonstrated how a purchase parts supermarket in combination with the concept of risk pooling can help reduce the amount of safety stock an organization would need to hold without affecting customer service levels. While purchase parts supermarkets are a useful tool, we have to recognize that it may not be the answer to every inventory problem that a company has. Many of the benefits that we've outlined in this presentation are limited to situations where there is relatively high production volumes that run on a frequent, repeated basis. While this approach can be used for lower volume, infrequently run components, the benefits of risk pooling would be significantly reduced. And in these types of production environments, a purchase parts supermarket would most likely be beneficial in controlling inventory and communicating production schedules to the production area. The benefit in terms of inventory reduction would be significantly reduced, if any. So in conclusion, we'd both like to encourage you to consider implementing your own purchase parts supermarket. Dr. Harris and I have experience of implementing this type of a system in a number of different manufacturing environments and had good success in those instances. Under the right circumstances, the benefits and impact to your operating system can be significant. At this time, if you have questions, I guess we'll turn it back over to Chris to see.
Yes, thank you, Thomas and Chris. We do have a few questions that are coming in, and of course, if you have any questions right now and you haven't asked that yet, please feel free to submit a question. You'll just see a questions box to the right of your screen, and type your question in the box and send it along. So let's get started. Let's go with a question from Sushil. This is, if there is a breakage at production, then wouldn't it be a good idea to stop the bus, and how might you handle that situation? And let me know if you need me to repeat that.
It's a good question, and so, no, I'm good. I've got this question quite a few times. There's two schools of thought, right? Because if you take it back to the market, now you've got to figure out a way to signal it to go back. Now, the other school of thought is that if you can find a way to drop that material there without it being a safety hazard, but somehow signal an abnormal condition, now you not only, your system's not only still in place, but you've also signaled an abnormal condition. And this, as long as that bus route continues to go by, there's a valve that shuts it off. That's why you calculate the number of pull signals. Because once that third pull signal in our example went, no more can go. And so therefore, when that starts back up, then it's just going to start right back to where it was, and you have no need to take it back.
The other thing that you need to consider is that this component may be used at other parts of the facility that may be still up and running. So your bus would want to continue to run to service the other areas, as even if you had one section of the facility that was down.
Okay, great. Thank you. We have, let's go right down the line. We have another question. And what happens if your product is of a seasonal nature, like an air cooler? How can you incorporate this into your system?
I don't know exactly what. I would like to have more detail on the question, but I can say it like this, right? So let's say it is seasonal, and if it's an air cooler, I'm assuming your heavy time to run would be in the winter to get ready for the summer. That's my assumption. If you're going to run it one way during the winter and then another way during the summer, because what would happen is your average hourly usage would change, or if you were still running it. So if your average hourly usage changed, you would still run the bus route. There would just be less on the bus route to deliver the production area.
Essentially, you have to recalculate your cam ends for the system depending upon the season.
Right. Your pull signals would have to be recalculated,
assuming that you run year-round, just different volumes at different times of the year. Yes.
Okay, and I'm seeing a variation of the next question coming up from a few different people, so I'm going to kind of combine questions. In general, we're talking about situations where you have a very long lead time, like, for example, 8 weeks. What are some strategies you might use to handle a long lead time item?
Well, I think the next question you have to ask right after the long lead time is, how often do you run it? Because there's two different situations. I'll talk about both of them. The first one is, if you have a long lead time part that you don't run very often, I'm probably not going to carry that in my purchase parts supermarket all the time. I'm going to have a section of my purchase parts supermarket that's dedicated just to running what I would call a stranger, right? One that you run very rarely. And then that's one of the exceptions to the supermarket rule, where everything has its own place. There's just one place in the supermarket for those strangers. Now, it changes if you run that part every day and you run a lot of them. Then I would say the 8-week lead time doesn't play into the bus route, because as long as that pipeline's full, it's much more important how often you receive the material than the lead time, assuming that the pipeline is full. So let's say it's an 8-week lead time, but you're ordering it every week and you're getting it every week. Well, then in that case, my maximum inventory level in my market is going to be a week's worth of material plus my safety stock, and I'm going to deliver it to the production floor as usual. So I think the question is twofold, right? It's a good question, but how you answer it depends upon whether it is a stranger, a part you don't run very often, or one that you run frequently.
Okay, I hope that helps. Our next question is from Aniket, and he's asking, would you recommend planning a supermarket for only A-class items, or would you say this should go for all items?
Well, we've always been of the belief, and when I say we, I'm talking about a group that I've worked with, that you need one purchase parts supermarket for all purchase components. Because the side benefits that come from that we didn't talk about here, but at some point I would like to get to where my schedule and my parts are released from that supermarket. So in that case, I'm still getting the organization, I'm getting the benefits of having a smaller group trained to move material, and then I can deliver them to the production floor at the same time, the schedule and the parts. Also, the thing that we need to think about are the inefficiencies that come about when you have the operator get their own components. Because now you take a value-added operator and you say, stop what you're doing, stop adding value, and go get a component. The third thing that I would say is, some of you may be different, but in the vast majority of facilities that I've seen, when parts are stored on the production floor, we lose control. Now, I've heard this quite a few times. They're in the system, but that doesn't necessarily mean they're right here. For example, I think that probably many of you, I know that I've run across this many times, you've expedited parts that you already had in the plant. Like, that's a common thing to do. Well, how does that happen? We don't have control. So even if you are running something that's a very low runner, you can gain a lot of benefit from a purchase parts supermarket in the form of organization, taking the schedule and the parts out to the floor, and being able to just not have that chaos on the floor. The other thing is, the only true way to control production, right, because sometimes production will make something that maybe they weren't scheduled to make. The only true way to control production is the material that you deliver them. So if you're in a make-to-order, you only want them to make 5, and you deliver them enough components to make 5. They can't make 6, and they can't make the wrong thing. So that would be another benefit to a supermarket in that environment.
Yeah, no, I would just add to that, I actually had a similar type of situation where we did this with all of our items, A, B, even C items, at least for small components. And the control was the biggest advantage that we got out of that, simply because those types of items tend to run infrequently. They're easily lost, as Dr. Harris pointed out. And when you have them in a secure central area where there's just a limited number of people who have access and control over those components, it's much easier to control that inventory and know where it is when you need it.
Okay, thank you. Our next question is, are you guys able to share the safety stock formula that you were using in an earlier example?
I don't know that we ever did a safety stock formula. That's a little outside of the scope of what we're trying to do. What we're just trying to show is that through a lean system that we're talking about and having all those purchase components in one place, we can benefit from the pooling risk. I'm assuming this is probably the slide that they wanted to see when we took all of it, aggregated it together, and then just recalculated. But all we're trying to show here is how you can benefit on the concept of risk pooling to help to lower that safety stock.
Okay, I understand. I hope that helps. Our next question is about, well, it's a bit of an open-ended question, so I'll let you guys approach it any way you'd like to. Are you aware of any downsides of using risk pooling when you're dealing with a global supply chain?
That's a really good question because the concept of risk pooling is very quantitative, and so it's kind of just a numbers game, right? When you aggregate, you got the standard deviation. When you deal with a supplier that maybe they have problems, maybe that lead time's so big it has problems, that adds another area into the calculation.
Yeah. So. Essentially, when you talk about the risk pooling and the safety stock benefits that you gain from this, it really does become a function of what level of service or confidence you want to have with respect to being able to satisfy demand. And then it also becomes a function of how much variation exists in your supply chain. And so in order to calculate, whether it's global or local, really the safety stock component of this is dependent upon how much variation you observe within your supply chain from period to period. And so my expectation would be if you have a longer supply chain that stretches around the globe, then you probably wouldn't have higher, as we would expect, we probably would have some higher safety stock to compensate for that. The other thing that we have to keep in mind here is, right, when we talk about safety stock, we're not actually considering expediting product in. So when you do have issues with a long supply chain, you do have the option to expedite material in, as opposed to being on a boat. It could be on a plane in many circumstances, maybe not every circumstance. So from my perspective, I think you still have the ability to gain from that, because again, if you don't aggregate this into one central location, you treat all the different usage points independently, the amount of variation that you might see there would tend to be higher, and so you're going to have higher safety stock levels as a result of that.
And there's another side of this that is, there's almost a political component to this as well, right? Because you have an end customer that you want to make sure you never run out of products for them. I mean, you're willing to carry a lot more just to make them happy. And I think that's worthy of note, even though there's no way for us to calculate that. I know that could possibly happen. So, for example, if you've got a supplier, they're 40% of your business, you want to make sure you keep them happy. You know, maybe all these numbers are out the window and you're carrying a whole lot to make sure that you keep them happy.
Absolutely. Well, it looks like we're kind of winding down our list of questions, so I just want to invite, since we have a little bit more time left, invite everybody that you can still feel free to send a question in, and we'll try to get to it. I will address one other point that's was been asked by several people. If you would like to get a copy of today's slide deck, please feel free to email editorial@apics.org. That's editorial@apics.org, or of course the authors and presenters will be happy to share it as well. But I can send you a PDF of the slides today if you'd like. So I'll go to one other question that was sort of a clarification on an earlier one. This was about the sort of long lead time supply chains, and Andy would just like to see if you could clarify one point. What about the example of when you're using multiple distribution points in different regions that are selling the same items? I hope that makes sense to you guys, because it's a little over my head, but is that clear?
It is. I'd have to think about it for a second. So if I understand the question correctly, then you've got the same component that you can get from multiple sources within your supply chain.
So is this, can you ask the clarification question, is this that they distribute from more than one, or you get the purchase component from more than one supplier? Because I think that we kind of heard it two ways.
Yeah, I'm sorry about that. Well, let's let Andy get back to us, and in the meantime, why don't we try a different question? I have to sort of process this one. Give me one sec. Okay, great. So this question is from Christy, and she's asking, if production would come across concealed damage after a bus was delivered, how would the damage be handled?
Well, this is a really good question. This comes up quite frequently, and there's not a good way to do it, which makes sense, right? Because you got a quality problem. There's no good way to really deal with a quality problem. The hope would be that it's so rare that when it happens, it's an emergency, that it runs up there. Now, also remember, we've got an hour's buffer out there. Assuming that other hour is not bad as well, we can be okay. But what it's going to end up doing is driving us back to taking a look at our supply base again and say, well, wait a minute, how often does this happen and why does it happen? Because it will hurt this. Poor quality is going to hurt the system no matter what we do. With this, we do have an hour buffer. And the other thing that I would add is that if you've got a decoupled route, then you've got somebody else back in the supermarket that could make an emergency run out to the floor as well. But I really want to be careful not to design into my system that these quality problems would be okay. I want to make sure that they're known and that they can be addressed quickly.
Okay, great. Let's see trying to see if we can get better clarification on the previous question, but I'm not sure it's coming up yet. Let's try. Yes.
Again, and maybe I misunderstood the question that Andy asked, but what I thought you said was that he basically had incoming material from multiple suppliers or locations into his facility. If that's what what I understood. The one thing I would say is when we talk about calculating safety stock requirements, it really just becomes a function of the lead time and the amount of variation that's in your lead time and the amount of variation that you have in the demand for that component. And so while you would have to come to some acceptable average or combined lead time variation and demand variation, I don't think it matters whether you have multiple sites supplying your location.
The only issue would be from a quality control standpoint, right? If you have the same part number coming from multiple suppliers and you have a quality problem, if they're all the same part number, how do you track that quality issue back? Would be a possible issue, but that's another subject matter for another day, more than likely.
Yeah, yes, it may well be. Well, Andy, I hope that helps you. If not, please feel free to send a question to Chris and Tom and their contact information on the screen. And I think with that, we're probably going to wind it down. If we weren't able to get to your question, please feel free to send it along, and we'll try to address everything. Well, Chris and Thomas, thank you so much for your time today. This was a great webinar.
Thank you. Thank you very much.
Okay, and so with that, we're going to conclude this edition of APICS Extra Live. All content and materials included in this edition of APICS Extra Live are the property of APICS and Chris Harris and Thomas Parker and are protected by the United States and international copyright laws. All rights are reserved.